Rate of change. So this concept's probably going to come up fairly early in the calculus class. Notice this is the formula for rate of change up here, but I wanted to put this notation in. Those little triangle shapes, those are deltas in the Greek alphabet, so that's delta y over delta x. They use delta a lot to mean change, so it means the change in y over the change in x. And then you can see over here this formula, which we've seen that before, but f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. It's similar to the slope formula when we were doing linear equations. Okay, on this first example, they give us a table of information, and it looks like these are different years, and that's the input, and then the price of the gasoline is the output, so average price I'm guessing. So it says find the average rate of change of the price of gasoline between 2007 and 2009. So 2007, that's going to be our input 1, and input 2 will be 2009. So 2007 for x sub 1 and 2009 for x sub 2. Then we have to find f of x sub 1. So what we want to know then is what was the average price of gas in 2007? And it looks like it was 2.84. And then f of x sub 2, that's going to be the gasoline in 2009, which was 2.41. You're getting that off the chart, okay, off the table. All right, now we can apply the rate of change formula. So f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. That's going to become then 2.41 minus 2.84 over 2009 minus 2007, 007. All right, and if you put that all in the calculator, you should get negative 0.215 is what I get. Now, I noticed they rounded it off, so approximately negative 0.22. So what does all that mean? How do we interpret it? Well, between the years 2007, 2009, it was decreasing. The gasoline prices were decreasing at an average rate of 22 cents a gallon. So that, I don't remember gas going down, but it must have been true. Okay. So that's how you interpret it, and that's how you do a problem with table information. Okay, so let's look at another example where we have an equation given to us for a function. And they want us to compute the average rate of change, and they give us an interval from the points where the inputs are 2 and 4. So this is like my x sub 1, and this is going to be my x sub 2. Now I'm going to have to find f of x sub 1. So that's going to be f of 2, and then I'll have to plug that in. So 2 squared minus 1 over 2, which is going to be, I'll just write it over here. 4 minus a half, so what's that, 3.5 or 3.5? I'll just make it a 3.5. Ooh, we'll go for it like that with a decimal, but that's okay. So now we have to find f of x sub 2, which is going to be f of 4. That's the end of our interval. So 4 squared minus 1/4. 16, so it's what, 15.75 if you go with a decimal. I started with those decimals, so I guess I'm keeping them. All right. I think that looks right. Okay. Now we can plug it into that formula. So it's, again, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. And so for us, we're going to have 15.75 minus 3.5. I really should have gone with fractions, I can tell. I should have left those decimals behind. And then, what do we have? 4 minus 2. So then we're going to get, I didn't do this on the calculator, but It's going to be 12.25 over 2. And then let me just do that on the calculator real quick. 12.25 divided by 2. 6. I don't know why I went with this one. 6.125. Now, if I wanted to make that into a fraction, I could do that. So it'd be 6,125 over 1,000. We'll just have a little bit of fun here. So let's see if that's divisible by 25. It is. So you get, now I'm in a big fraction thing. 245 over 400. I think that's divisible by 5. So what do we get? I think we're finally going to get to the book answer here. Not that that's always the most important thing. So divide by 5, we're going to get 49. And divide the bottom by 5, we're going to get 80. So 49 over 80. Let me just double check, make sure my math's okay. All right, and this is, I'm off a decimal because it wasn't 40, it wasn't 400. Okay, that's my bad. We're gonna live on forever in video form. Okay, it was a 40 here, and that made it an 8. So, the decimal answer was okay, but I decided to change it to the fraction just because. So, okay, that a little bit longer on that one. Then that was the that example, and we have one more. So this time we have an x sub 1 of 0, but our x sub 2 is a, which is a variable. So we can plug in, we can find g of 0. And when you plug that in, you're just going to get 1, right? And then you can find g of a, which is going to be a squared plus 3a plus 1. So that's okay. Now, if we go ahead and plug those in, so if we have g of a minus g of 0, and then we're going to have it over a minus 0, then that's going to become a squared plus 3a plus 1 minus 1 over a. So, I don't know why I'm going so quickly on this, but you plug in the 0 and you get 1. You plug in the a and you get a squared plus 3a plus 1. Now we go to that rate of change formula right here. So we're subtracting g of a minus g of 0 and then over a minus 0. Now we do want to simplify that. So it's going to be a squared plus 3a over a. We need to continue to factor. So in the numerator, a times a plus 3 over a, and those a's cancel, and so our final answer is just a plus 3. Okay, there we go.